Welcome to my project bazaar.com. Performance evaluation of different segmentation techniques for underwater images. The segmentation is the process of separate the desired part of original images from many color transformation processes. In this process, we have to segment the underwater images by different powerful techniques as follows. After segment the all images, we propose the evaluation of performance of the images to defining which segmenting technique is efficient than another technique. The segmentation process is a useful method to process of dividing the image into multiple parts. Basically, the segmentation is used to identify the objects or other relevant information in the digital images. In these processes, we have to segment the underwater images by using different techniques to evaluate the performance of many methods of segmentation from one to another. This is the flowchart of our process segmentation of underwater images using different powerful techniques. The first step, we have to take the input image as the underwater image. The underwater image is obtained to different powerful techniques such as edge reduction, k-means method, and threshold calculation. Finally, we have to perform the evaluation of the used segmentation methods. First of all, we have to take the input underwater image to obtain the some pre-processing techniques. Which process helps to prepare the input image as our proposed work. In pre-process, the input phase to be pre-processed such as grayscaled, filtered, and then enhanced for the feature extraction process. Then the feature values are extracted from the input image for the segment the multi parts. Following process, we have to see the edge detection segmentation method. This is the one of the powerful segmentation method is to based on ranges at the image pixels. In this process, we use the canny method to use it for detecting the edges on the input image. In this edge detecting, the threshold values get from the sensitivity of the input images. In the edge detection, input value automatically evaluate the high values to calculate the edge values of the two element vector of the input image. The next step is powerful as k-means clustering. They easily segment the input image in this process. This segmenting process is very powerful to removing the masking in the input images, to using the mean values efficiently to obtain the segmented image in the k-means clustering technique. The pixel variations of the color transformation should be managed perfectly in this process of segmentation. The final process of our segmentation technique is a threshold calculation. This threshold calculation method is powerful segmentation method to segment the input image efficiently to using the color transformation. By applying the color transformation to separate the image to red, green, and blue parts of an input image, to the segment the image pixel from using the threshold values from the each pixel of an input image. After segment the all parts as RGB of the image, finally concatenate the all parts at the single image value. The final process of our segmenting process is this performance evaluation. This evaluation method to measure the performance of the segmented image using the three concurrent segmentation methods such as edge reduction, k-means method, and also the threshold calculation. Using PSNR calculation to evaluate the performance of the segmented image. This is very useful to know those segmentation methods to how works and what is performance ranges occurs on the each methods of our segmentation. Is caused by absorption, scattering, which influence the overall performance of underwater imaging system. Forward scattering generally leads to blur of the image features. On the other hand, back scattering generally limits the contrast of the images, generating the characteristics while that superimposes itself on the image and hides these. The absorption and scattering the effects are not only due to the water itself but also due to the components such as dissolved organic matter. The visibility range can be increased with the artificial illumination of light on the object, but it produces non-uniform of the light on the surface of the object and producing a bright spot in the center of the image with poorly illuminated area surrounding it. The underwater image processing area has received considerable attention within the last decades, showing important achievements. This paper has to the review on some of the most recent methods that have been specifically developed for the underwater scenarios. These methods are capable of extending the range of underwater image processing, improving image contrast level and resolution quality after the consideration of the basic physics of the light propagation in the water medium. We focus on the different method available in the previous articles, the situation for which all them have been firstly developed or highlighted, as well as quality assessment methods used to evaluate the performance. This is the Matlab main window. In that main window we have to select the current folder. That current folder select the GUI.main file. Then right click the GUI.main file, click the run button. After clicking the run button, we have to receive the first input window of our process. In that input window, we have to select the input button. The input button is a representation of when we'll receive the input image from the system. We have to select that first input image. Then we have to apply the pre-processing of that input image. This is the noise reduction image and our output image of our pre-processing technique. And then clicking the RGB button. After clicking the RGB button, we have to receive the three display. The three displays represents now red, green and blue image of our input process. Then go to the main display. In that main display, we have to see the three powerful techniques of our segmentation technique. The segmentation techniques are such as edge reduction, threshold and k-means. Clicking the edge reduction method, we have to receive the edge reduction image of canny edge reduction image. After clicking the thresholding, this is a representation of input images. Thresholding ranges from our input underwater images. And then finally clicking the k-means clustering. This is the third powerful technique of segmentation in our process. Clicking after the k-means clustering, we have to receive the two window of our process. The first window from the hue, saturation and intensity image of our input process, and then we have to the second window in the different cluster levels of our input images. The four object in cluster 1, cluster 2, cluster 3 and cluster 4 images we have to receive from after the k-means clustering. The final image is a labeled image cluster index that, and then finally we have to evaluate the performance of three segmentation technique. Clicking the performance button, we have to receive the MSE value, mean square error rate value and PSNR values for our each segmentation techniques of our input image. Then finally we have to graph simulation result for input image as a segmentation process from the different powerful techniques of. Thank you.